welcome everyone. I'm Michal Hanzlík from Microsoft, and I would like to tell you something about conditional middlewares in ASP.NET Core and one specific use case that we recently implemented. And I will also talk about the motivation, why we did it that way, and also the reason why I'm talking about it here is that a few months back, there was an amazing talk from Jarda here about this very same thing, and this makes me made me think about, hey, this is actually a good use case for it. So let's try to leverage it. Now it's fully in production, it's working flawlessly. So me personally, I'm very happy about how it got implemented, and it's helping us big time now. So actually first, so conditional middlewares means that you only apply the middleware under certain conditions. And these conditions can be pretty much whatever you want because you have access to HTTP context. There you can, for example, do conditions against path, against host, against request query, headers, whatever you like. And it's pretty flexible. So in our case, it helped us to loosely couple service components. That's one of the main benefits, that you can have different components. Typically, you may have some kind of eShop with the front end, and then some UI for the backend for the administrators, and there you want to run some authorization. So using this conditional middleware, you can just have the authorization in place for certain subpath or something like that, and it's clean because you don't need to run it in every controller. So in our case, we introduced it because we are trying to reduce the legacy we have in Skype, and there is a lot of it. And back then, there used to be many people, and the managers were trying to find work for them. So everybody was creating microservices, and there is so many microservices that you can't even count them. So what we are trying to do now is to have one microservice which is hosting multiple different hosts, because these hosts were usually performing some very simple operation, and it doesn't make sense to have like full stack service for such a simple things like serving redirects. Yeah. And we are basically introduced this multi-host support, and one of the important things was that, for example, you cannot have colliding paths. So, or you somehow need to deal with that, because typically you have root path, which must be addressed somehow, and if you have multiple different domains hosted on the same service, then how do you deal with that? Then we come up with one approach which works quite well using the conditional middlewares. So now, how do you map hosts? So it's fairly simple. You have some dictionary where you map the host, like the domain, to some enum value. You have the enum, and then you have some very simple class or struct, whatever, where you just do the mapping. And this mapping, these are paths, request paths, or path prefixes, as we will see over here, how it can be used. So this is the body of the middleware, the main one, which is mapping the host. So when we get a request, from request context, you can get host, and you just try to get the known site for it, and then you map it to path prefix and prefix the path. And this is transparent to the user. They will never see the prefix itself. It's just for the service internals to be able to distinguish between different routes, because then you need to somehow do the routing to controllers. And this way you can have the same paths for different domains, but they won't collide because they will have different prefix, so it will get resolved properly to the correct controller action. And yeah, for at least this was our decision, that if, for example, somebody accesses the service using IP address, then we return 404. We don't want people to do that. It's usually some malicious requests, and it doesn't make sense to serve that. And now this is how the conditional middlewares look like. So over here, first you need to apply the middleware we see on the previous screen to do the resolution and update of the path. And then based on your site, you just apply the middlewares that you are interested in. Also, when Jarda was talking about it last time, there is also another approach. Over here we are using useWhen. You could also use so-called useMap. The difference is that over here, after this useWhen, the flow continues, and you can, for example, I don't know, apply another middleware which will be global, for example, for some telemetry purposes or whatever. If you would do useMap, then it stops there. The first useMap that got hit just stops the middleware pipeline, and might be even, in some cases, it might be even used as some kind of optimization, so that you don't need to run this method multiple times for all the different sites. So now, since we are able to just apply specific middlewares that are executed for different hosts, what about the request path? So that's very simple. You just, on the class level, you just apply this route attribute with the respective path prefix, and then you just proceed as you would do normally. Here, this is for the root path, and then you can have other methods for different paths. So from here, it's very straightforward. And the benefits, so clear benefit is less maintenance, at least in our case. At this point, we already were able to merge 4 different services into this single solution. So when we are getting some security bugs to upgrade packages, etc., we just need to do it once and do one release instead of 4. So that's a huge time saver. And also, this service is on the modern stack, .NET 8, modern library, so it's much easier to maintain it than something on .NET Framework and OWIN and perf counters, etc. There is a strict separation between hosts, so using this approach, there is no risk that you will serve one thing on different hosts, like, I don't know, provide some Teams page on Skype.com page or something like that. So this cannot happen because there is this strict separation on the path prefixes. For the routing, there is this additional protection from the spammers because we only serve requests that are for the specific hosts and we drop the rest. And also it saves us the resources because we don't need to process the requests. And also we can reuse more components because many times you write some stuff like some helper methods, utility classes, etc., or stuff around configuration, and this can be very well reused for all the different hosts. So that also saves quite significant amount of time. Also, you don't need to write the tests for it multiple times, etc. So that's about it. Do you have any questions?
So you mentioned that we are on .NET 8, and I noticed that there is a dictionary. Have you considered using frozen dictionary instead, because you can save a couple nanoseconds as its hot path?
Right. Yeah. This was a simplified version, because in reality we are loading it dynamically from ECS, which is like a configuration system, and so that you have an option to override it dynamically in runtime. So actually that uses dictionary as well, but there is a chance that it will change.
Oh yeah, got it.
Yeah, but good point. .NET 8 definitely provides these optimized collections for certain scenarios.
Okay.
Thanks.
You mentioned that a single example of authentication, for example, based on a path, as a single middleware to add that. I'm wondering how it goes with combining multiple middlewares at the same time and stacking them on top of each other, and maybe taking some precedence, and how the code gets organized when you compile or like put those middlewares together.
Right. So here basically you can put multiple middlewares. So what this does is that it pretty much executes this very same thing, just only when it matches this condition. So you can have multiple middlewares registered here in each of the conditions. So that way you can even register the same middleware twice or multiple times. So it works the very same way. So typically in our real scenario, we have all the telemetry first, and then like error handling, 404 handling, etc. And only after that we apply these conditional middlewares. And for some cases we have like 2 or 3, and sometimes for some of the pages we have none, because it's so simple that it doesn't require any extra handling. If it answers your question.
Yeah, thank you.
Cool. Thanks.
Thank you, Michal, for presentation. I have a couple questions. First question is, did you observe any negatives? Because you mentioned a lot of benefits, but have you observed any negative compared to the previous state, which was multiple microservices?
Right. Well, you may consider it a negative thing. Once we released it, in metrics, we suddenly saw different paths, because now they were all locked with the prefix. So we had to a little bit readjust the monitoring, because suddenly the traffic for the paths which were there dropped to 0, and the new paths with the prefixes got the traffic instead. So that was one of the issue. And the other thing which one must be a little bit careful about is that this is executed pretty early in the process, even before we run the regular login and metering. So here we had to really have like solid metrics, solid error handling, and monitor for the metrics, so that we are sure that this component itself is not causing trouble. So it's not really a negative, it's just that you need to be extra careful when implementing this, because there is this side effect.
Yeah, this was actually my second question. I wanted to ask about the alerting and monitoring, but you kind of answered. So if I understand correctly, you now have unified, alert metrics and whatnot for all those 4 services which you unified.
Yeah.
However, all the specific monitors were rendered useless because they immediately had these different paths because you're attaching this prefix.
Yes.
So, and have you added some new dimension to distinguish it in the metrics, or 2 services have same paths basically? Like, how do you handle such monitor?
Then in the request path, you will always see the path with the prefix.
Okay, so you will have like host prefix. So you have to rewrite all the monitors to make sure that for service A, I will have A index, and then for B, B index, so change all the monitors.
Yeah, but well, majority of the monitors we have are generic, so that it's for all the paths. So it wasn't that we would have to go one by one.
So the only custom one which you had to make is in these early stages before actually the mapping happens,
Yes.
right? So you added something there which is custom and
Exactly, and that's like, for example, if we see too many drops to this 404, then that's suspicious. Or we had some. Sorry, where is it?
oh, that's actually 404. Yeah, how do you handle like 404s for different services?
In this case, we just show, we just send the response with just 404 status code, because this is clearly a request we don't want to serve. So we don't return any HTML, but for the websites, there is like a regular 404 page with some graphics. And for API, we again just serve 404 with the headers, but there we serve it with like the correlation vectors and stuff for debugging purposes. Yeah, and here, in reality, this is doing try catch in case this mapping fails. So just so that we are also aware.
The last question, and then I'll pass it to others. How many more services are you planning to migrate to this one?
So now there are 4. There will be definitely one more, and which is GoLinks. That's also again just redirects pretty much, and very simple database. And yeah, that's pretty much it for now.
So most likely 5 in the near
Yeah.
future. All right. Thank
But
you.
it's a good candidate for some other similarly simple stuff.
Yeah, thank you. My question is actually a follow-up to Stepan's. So based on your experience, have you developed some decision metrics based on which you decide whether this microservice is a good candidate to be rewritten to this monolithic structure? So
Yeah.
main criteria based on which you decide.
It's not so rigorous, but we have an Excel file where we have the list of services with the properties. So for example, yeah, this service is on .NET Framework, it's poorly maintained, so it might be a good candidate to move it over here. But then again, another criteria is how complex the service is, whether it makes sense to just move the simple business logic here, or if it's too complex, then we would probably have to stick with a new service, just like move the business logic to a new shell on modern .NET. So yeah, so far, as I said, we had a bunch of these services which are super simple, so they were like a clear candidate, and it took very little time to move them over. And yeah, we will see in time whether something else will make sense or not.
Okay, thank you.
I'm just curious what you do mean by a very little time.
Oh, like, for example, we were moving download service for Skype, but there are 2 download services. One is serving only redirects, and the other one is just providing access to blob storage, and it just runs authorization. That's it. So the first one, which is serving the redirects, it took like 3 weeks of time to fully move the business logic to this new service. So yeah, considering Microsoft standards, that's very little time.
Yeah, thank you.
Does that mean if you take the redirect service somehow offline, then the download service will die as well?
Oh yeah, totally. Because then there is this auto update in client, and that keeps pinging the redirect service, because it either serves 204, no content, or 302, which is like a link to this blob storage. So if it dies, then this auto update will just stop working, even though there might be new packages published in the blob storage, but they won't be found by the client.
Okay, so basically it makes sense to put the same related services into the same monolithic structure. Instead of like, I have 5 different independent microservices, let's put them into one application, let's somehow save the money.
Yeah. Also from this like resiliency perspective, if you have one service, then you are more likely to find time to have like a proper deployment patterns, redundancy, monitoring, etc., or some fallback scenarios or failover scenarios than if you have 5. So this is better also from this perspective.
And you're limited with the geolocation, for example. You know, if you want for the different services different speed and whatnot, geolocations, like this just gives you one infrastructure and that's it. So plus and cons.
Cool. Okay. Thank you very much.
The last time we had ASP.NET authentication, and they always attack into, right? So this time we will take a look on ASP.NET authorization. And again, our goal is to kind of get through the part of the framework and understand how it works, and hopefully see that it's not a rocket science, that it's mostly pretty straightforward and ready to be used by you. So let's start with a small recap from the last meetup about identity. So we can find identity of the user in HTTP context, in HTTP context.user, and there is something called claims principal, and this claims principal stores identities. So the identity is what the user is. It stores claims, and a claim is something that is true about the user. So we just take a quick look. There we see that there is a hierarchy of interfaces, and there are implementations on the left side, and we will today be mostly concerned with claims because we will use them for authorization. So if we start with authorization, what's really authorization? Yeah, we talked about authentication when we wanted to know who you are, or let's say to know if you really are who you say you are, right? And that's fine. So now we know who you are, we think. And now we need to know if you can do what you want, yeah, with our precious system. So we have some requirements on you for the operation that you want to do. And this requirement is really expressed by this interface. Oh my. Oh, okay. It looked different the last time, but I will cope with it. So this authorization requirement, you see that it's an empty interface, right? It's called, if you like it, you call it label interface. If you don't like it, you call it an anti-pattern, right? But this time it's not really an anti-pattern because of 2 reasons. First, it's created by .NET and they don't do anti-patterns, not so whatsoever. Yeah. And the second reason is that this authorization requirement isn't there to be used as it stands. Yeah, it's there to be inherited by you. And here we have an example. It's called minimum age requirement. By the way, have you ever seen this example? You know, this is from MSDN. So I just copied this minimum age requirement from MSDN, and you see that it has only one property, and that's the minimum age. Yeah. So this requirement, its role is that you may do you may want to do something that you need to have, some minimal age, let's say, to download some content, and you need to be over 18, So it has just a constructor to fill it with value. So what if it, The point of this interface is that it's handled by an authorization handler. And this authorization handler, you may see that it uses something called context here, but this context is an HTTP context. It's authorization handler context. And in this context, we have all the requirements for a resource that we want to use. For example, you don't have to need to be over 18 only. You have to be male, Maybe in 18th century, of course. But, there might be more requirements for you to do some operations. And these handlers will just pick these handlers that have known type or the type that they are interested in. In our case, we would have some over 18 handler, and it would be interested in this minimum age requirement type. So it will take it, and it will check if there is a claim in the principal, and in this claim there is an age, and the age is more than 18, or maybe there is a birthday, and the birthday is more than 18 years ago. So this iAuthorization handler is an interface that only has this one method, and .NET already created for us an abstract class that does this heavy lifting. So we will only need to write a very little code. We will see an example in the end of our own custom handler. So we see that we have these handlers, and really the handlers only look for the requirements, and it's more or less the same pattern that we saw in authentication with authentication handlers, and that we, for example, see in Mediator. And this pattern is chain of responsibility. So the idea is that you have some starting point, usually it's called a client, and then you have couple handlers that may know how to deal with a request. So we send it to the first. If it knows, it will handle the request. If not, we will send it to the second, etc. And finally, we will either find the handler that can handle the request, or we don't find any, and we will need to solve it somehow. In the end, the same pattern applies on the middleware pipeline. And in the case of ASP.NET authorization, you have the requirement, and for each of the requirement, you will try to find that handler. That handler, if it can be, it doesn't have to be sure, If the handler isn't sure, it will just say, okay, I have no result. And some other handler will say, okay, this is a success because the person is over 18, or a failure because it's not, obviously. So then we should end with three possible states. It's either success or failure, or we didn't find any handler. And there is some authority in the end that will create some authorization result, and it will reflect then the runtime will then reflect the result. And sorry, the point of this pattern here is mostly the extensibility, that we can write our own requirements, but it's well isolated as well, because each requirement and handler only has very little code. And another fine, let's say, side effect is that we can easily model the OR behavior, because if the handlers works the way that I just described, they pretty much worked in the OR manner, So you are fine if you will amuse just one of them, So these requirements are kept in something called authorization policy, and this authorization policy is something like a central point that keeps requirements and keeps schemes, yeah? Because maybe we are only interested in throwing the requirement on a user that is using some particular scheme, yeah? Let's say that he's using remote scheme, for example, OAuth or something like that, and we then want more requirements on him than if he's, for example, locked in Windows, yeah? Because when you are locked in Windows, you need to be a good man, so no need to authorization then. And this class really has this purpose of keeping the requirements, the schemes for the policy, and to combine them. So we may say that we have a couple of requirements and we call it somehow, that's the policy, and we then can combine easily policies. And here is a little, let's say, longer part of code, but we will get there a bit later. So, to build a policy can be a bit tedious job. So we have authorization policy builder to help us a bit. This authorization policy builder has methods to do, let's say, usual requirements, the most used, let's say. So, for example, we can require a claim. Yeah, that's a typical requirement, or a role, or maybe a username, and etc. Yeah, these are like a typical scenarios for requirements, and we can just use them out of the box. So this authorization policy builder, there is really nothing that can't be done other way. It's more a syntactic sugar for it. So enough talking. Let's say we want to have this authorization, in our application because it's great, and we create a builder in our startup or in our program CS file, and then we need to usually add authentication, because without authentication we won't have some classes that we need, I guess, and then the add authorization. With just this, you have the core functionality pretty much in place. There are some overloads, of course. There is an overload with options. If you want to set some default policies, or maybe your policies on your own policies and things like that, we will see that in an example in the end. Then we build the application, and then we need to use this use authorization. And this use authorization we need because it adds a middleware. We will see the middleware, and that middleware will like start the job. So we added the classes, we added the middlewares, and now you know how to make it working, right? So this example is from a controller. You see that there is a couple methods. I had to call them, these strange names because I couldn't just name them all post. So could be post as well, but this is for just this purpose. And we have a couple default ways how to use it. First, we don't have to use it at all. Yeah, this endpoint will be accessible to pretty much anyone. Then we can just use authorize, and this time it will only check if the user is authenticated, nothing else, right? The third is to constrain the authentication schemes. What will happen it will try to run the authentication schemes that you have here, like all of them, and then it will check if the user is authenticated at least by one of the two. Then, by default, we have roles because they are quite often to be checked. And here we have example with admin and owner roles. And one thing, if you use the roles this way, they are in OR manner. So you have to be either admin or owner. Of course, you can be both. And this specifically will check a claim that has this very long safe name ending with role. So the last one is a policy. Yeah, that's a tricky thing because we have this minimum age, yeah, that we had in the start. That's pretty much a policy because we add it in our policies. But pretty much all of these are policies. Yeah. This thing with roles and authentication schemes and maybe nothing at all or allow anonymous. These are only syntactic sugar for us, but under the hood, ASP.NET will create a policy for it and will use it the very same way as the last one.
The difference, if you could go back between the second and the third, meaning you have the authorize without any additional params, and one is with allow anonymous, and second is without. What's the difference?
Yeah, so this one is interesting by that you say that you want to have the user authenticated, yeah, that's authorized without anything, but at the same time you say that you allow anonymous users, so it will do nothing. That's just one option or possibility, because here
one cancels the other.
Yes, here it represents you won't have it in this fashion usually, yeah, but most likely you will have the authorize attribute on your controller, and you will have the allow anonymous on one or two methods, and basically it will do the same thing. But here I don't have the rest of the controller, so okay. But good eye. To be honest, I tried. Who will notice?
I imagine this could be some kind of workaround if you make a analyzer rule, for example, that all controller methods do not allow or do have authorized attribute on them. And then you have one specific method that you know that, okay, this one is safe to be accessible by all.
Yes, that's usually a login. You have a controller for login operations, and you need that one endpoint for the initial contact. So we will allow anonymous because at the point they don't have any cookie to prove who they are. Yeah. So. Yes, so the authorization middleware, yeah, that's really the part that starts the fun, and you may see that this middleware has rather straightforward logic. It will get the endpoint, the final endpoint, the resource. Then it will take metadata from the endpoint, and you may see that here is I authorize data, yeah, and this I authorize data is actually this attribute, yeah, because if we would take a look into this authorize attribute, we would see that it inherits from two things, yeah, first an attribute, and the second this I authorize data. And because of this I authorize data, I had this example here in policy, and you see that this combine async gets this I enumerable I authorize data, yeah, and this is the method that will kick in the very moment we are now in the middleware. So the middleware will take the metadata, and part of the metadata are attributes, and this I authorize data from the attributes, from the authorized attribute, and then it will use this authorization policy combine async, so it will effectively create a combined policy from all the attributes that you have there. Basically, what it means is that we had always only one authorized attribute, on the method. But what happens if there will be two? Yeah, it will be combined. So, for example, we have two rows here. We have admin and owner, and I need to be either of the two. Yeah, if I had two attributes, two authorized attribute, one will be with roles admin, and the second will be with role owner. I will need to be both. Yeah, so that's the end part. So we already have the OR part from the chain of responsibility pattern and from how the handlers with the requirements work, and now we have end as well. So we can have pretty much any combination we want, because as we know from logic, these two are enough to do whatever you want. So this middleware will then you create that combined policy, and then of course it will evaluate the policy. So it will use this I policy evaluator. You see that it's taken from the HTTP context, because this is request specific thing, because the I policy evaluator can have some state. I mean request related state. Then we authenticate the result, because we don't really know that the authentication already happened. Yeah, so if it didn't, we just trigger the authentication and we are sure. It won't happen twice. Yeah, we just check if something is there, and if it is, we will use it, of course. Then we will if it's anonymous. As you see, we saw that anonymous attribute there. If it's there, okay, we will pass it. So we just call the next middleware. If not, we will create or decide what is resource. Usually the resource is the HTTP context, but you may forbid it for your application for, say, higher security maybe, or some other reasons, and it might be the endpoint itself. So then you authorize the result. You will basically use the evaluator to check. It's the same evaluator like here. Yeah? It has two methods, authenticate and authorize. And it will basically check if everything is fine, if you fulfilled all the requirements. And then you handle the result. That's the last part, the decision part. So you have this authorization middleware result handler, handle async, and basically in this handle async is something like forbid and challenge. Yeah, the usual stuff when we don't want to give you something. Yeah, it's the same for authentication and for the authorization as well. So we mentioned the policy evaluator, and this policy evaluator have that two methods. Yeah, it takes all schemas from policy, and it will authenticate for each of the schemas, because we want to check if the requirements work for the schema set that we want. So we will take here, you see, for each scheme in authentication schemes, we will keep authenticating and combining or merging the resulting principle. Yeah, so it will have more and more identities. And then, if we were successful, we will send success. We will create a ticket for the resulting principle, and everything is shiny, right? So if it didn't go that well, we will maybe return another result. Maybe there is something in the result feature, as we remember from the last time. This is where the authentication results are stored. And then the second part is the authorization, and here it's pretty straightforward. It will just use the authorization service to do the job. Yeah, and that's why we will get to authorization service. And this authorization service really has two overloads, but one method, and that's authorize. And this authorize async will do the thing with handlers looking for requirements. It will create a context. That's the authorization context. So all the requirements are there, and then it will take all the handlers and let them to validate the requirements they are interested in. Yeah. So if we are successful, we run. Yeah, we call the evaluate on the context, because the success or failure are stored in the context, and then we return the result, whatever it is, because the decision point is higher. We saw it a slide before, and the second one is just an overload of the first one. So we saw that we have a lot of authorization or attribute options out of the box, and that's great, yeah. But maybe we want, something else, yeah. We don't fit into that typical use cases, and one use case that can be, or one of the use cases can be this. We want to really check the claims directly. Maybe we can create a policy for it, yeah, but we would end making like maybe hundreds or dozens of policies, because we, for example, have a legacy application that is just, one common host for multiple applications running under it, yeah, and each of the application has different requirements, but they all have in common that they use claims in the end. So we authenticate the user, and then we can say that we want to check some claims. So we create a claim requirement, and this claim requirement needs to say what claim we want, yeah, so it's the claim type, and then what value we expect. So we have the requirement, fine, and now we need a handler, yeah? So the handler will use this authorization handler abstract class, and now you see, that we only need this code, and actually this code is pretty vertically oriented, because I wanted it to be like a bit bigger, so it would be even smaller if we wanted. And we basically say that we take the context user, which is the principal, right? We will try to find that type, yeah, from the requirement, and we will check if the value is what we expect. Yeah, here we use ordinal ignore case, because usually it's the thing we want. Maybe in the requirement you can have the string comparison enum as well to be more sure about it. So if it's either not there, or if the value isn't what we expected, we know that we failed. Otherwise, we know that we succeed, because there is only one claim. We can of course do more claim in AND or fashion, because as you see, the extendability of this part of framework is really amazing. So we can do anything we need, and focus on our business logic rather than fight with the framework. So one thing, yeah. So we didn't really talk about how this claim requirement is filled, yeah. The built-in requirements are of course filled by the runtime, yeah, by other parts written by the .NET team. But you know, .NET team doesn't know about our use case with claims, yeah. So we need to change things a bit, and we need to create our own claim policy provider, and that's the part that will get a policy name, and on each policy name it will return that policy, yeah. So what we need is to have a deterministic relation between policy name and between the policy, because it's cached very aggressively. So you know, it would have pretty nasty behavior if we wouldn't do it in this fashion. So basically we will take a name, and in our case the name will have some prefix, and by the prefix we will understand that this name is that policy that we are interested in. Maybe we can take a look into the attribute for better understanding, and that means that I should have placed this one before that one, but don't say anyone. So here you have the authorized claim attribute. That's the attribute that we will in the end use on our methods, and you see that there is a prefix called claims for our use, and then you have these two parameters, the claim type and claim value, yeah. So they will now in the end they will be in the requirement, and we will create a policy name that is that has that prefix, the type, and the value. So it's deterministic always. The policy name will be for that combination of time and value, of type and value, sorry. So we take this name, and we can check if this policy name is, you know, that claims policy that we are interested in, because it starts with that policy prefix. If it's not, we will use that default authorization policy provider created by .NET team, because it's basically some default policy and they will do it well instead of us. If it starts with that prefix, we will extract the claim type and claim name and return a policy with that requirement. And this is the place where the requirement really sits. And you see it's allocated, but it doesn't matter because, as I mentioned, this is aggressively cached. So most likely it will happen only one for each name. So this attribute I already explained. And now the usage. We will only need to register two classes, that handler and that our version of authorization policy provider. Of course, this is a simple case that we are the final layer. Maybe if we would work with a framework, we would do some more complicated logic to take the previous version of authorization policy provider and tweak that one, yeah, and leave it there for the next developer to maybe tweak it again. And then we can use the attribute, yeah. So here we see that we have like two claims that we want to check. First is my name, so I will be the only one to have access, and the other one is some purpose, but it can be any claim. And as I mentioned, these two authorized attributes or requirements will be used in end fashion. So now this is pretty much all from the presentation. If you are interested, we may debug it a bit, but it's already 7 o'clock and we have some beer to drink and food to eat. So yeah, if you have any questions.
I don't want to spoil the excitement of the beer. I just was eagerly waiting for the labeling interface to be used somewhere. I just didn't see any usage at all of that, so I was wondering how it actually gets used. Is there any pattern?
Sure. I will move. I hope it's not too small. Okay. So, the only thing is that I now need to use this monitor. So we are interested in that labeling interface, right? So the place of the interface is really that I will inherit it, yeah, and that's it. Yeah, there is no contract that I would need to fulfill. I only label my claim with it, and the point of this I authorization requirement is that these handlers, let's say, to show the claim handler, these handlers have a constraint that you need to use it, so you can't use it, whatever type you want. So that's the point of the labeling interface that you will simply use, like that type inheriting it. But of course, if you have your favorite GAT class, yeah, we all have, but we don't tell anyone basically. But you can add I authorization requirement to your GAT class and use it there as well, right? So, but you shouldn't really do, and this should help you not doing it. Okay.
I was wondering, is there some alternative way to specify, okay, this controller methods need some, let's say, minimum age policy, but is there any other approach than use attribute to specify this?
Yeah, we have minimal APIs, right? And we don't really have this attribute options there. And then you can access the metadata of the endpoint directly and just add I authorize data on your own. You may create your own class. You can even instantiate the attribute, the authorized attribute, because it fulfills the interface, and you can fill your values there and it will behave all the same.
Thank you.
Okay, should that be all? Thank you all for your attention and enjoy the rest of the evening. Cheers.